Okay. We'll start off with some baby steps, right? We'll talk about solving some basic equations, and then we'll keep increasing the difficulty level as we go through. So the whole point, again, to be able to solve one step and what are called one-step and two-step equations. You're going to find out why they're called one-step and two-step equations. It's incredibly obvious why we call them that. We're going to talk about solving with one, in one variable, and you see the standards there that we're going to talk about. You can read those later. Some vocabulary, and again, guys, vocabulary is king. We want to make sure we're using proper terminology, so you're going to want to make sure that you study these vocabulary terms and know them very well and use them. Okay, when we discuss things in class, use them. The first one, an equation. An equation is a mathematical sentence that uses an equal sign, is what that says, an equal sign. It's very light, but it uses an equal sign. Okay? So, like what you wrote in the warm-up, those were two equations. I think you guys knew that. We need to use the idea of equivalent equations. Two equations are equivalent if they have the same solution. Okay? For example, and oh, by the way, equations don't have to have variables in them. Okay? Anything can be an equation. 10 equals 10 is an equation. It's a mathematical sentence that uses an equal sign. That satisfies the definition. Okay? Well, if we keep with that, 10 equals 10, an equivalent equation would be that. Okay? 10 plus 2 equals 10 plus 2. Those are still two equivalent equations. Take that a step further, and what makes a little bit more sense in the algebra world. That is an equation. X equals 5 is an equation. An equivalent equation for x equals 5 would be x plus 2 equals 5 plus 2, or x plus 2 equals 7. This guy right here is an equivalent equation to that guy right there. They have the same solution. Okay, we're going to use that idea to help us solve equations. Okay, all right. Another vocabulary term for you is isolate. If we want to isolate a variable, which is what we're going to want to do when solving, it means getting the variable with a coefficient of 1 alone on one side of the equation. We want to get in the variable with the coefficient of 1 alone on one side of the equation. Okay? And we'll talk about some ways to do that. Okay? And then we've actually talked about inverse operations before. You guys kind of took that right in stride. We didn't necessarily define inverse operations, but when we talked about, we had this in class before, you guys were right in line with what they are. But inverse operations are operations that undo one another. Right? We talked about square roots undo squaring. Right, the exponent, square exponent. And we'll continue to talk about inverse operations. That's how we isolate variables. It's by using inverse operations. Okay? But they're operations that undo one another. All right? Quick review. 4 little quick review problems here. I'm going to ask you to simplify. Go ahead and spend a couple of minutes simplifying those 4 down. We should be able to do this, or 3. There's only 3. Okay? and we'll come back and see how you did.
Oh.
Yeah. Go.
So first I multiplied 8 times 2x,
Okay.
and I got 16x.
Okay.
And then I multiplied 8 times 3.
Also called what? What are you doing there?
Distributive property.
Beautiful.
Yes.
And you got
8 times 3, and I got 24 on that.
positive 24?
Yeah. Wait, no, because there's negative sign in front of it.
Ah.
My bad.
So,
And then
yes.
I lost my spot. I was at negative 16x, right? Plus 3, right? Negative 24. And then I did 3 minus 16.
Okay. And what do you get?
Negative 13x minus 24.
Then what? Anything? Yeah, should be it, right? Right there. Okay. So we are going to still working on. We are going to still continue to work on simplifying a little bit there. Yeah, just make sure you take that minus sign with the 8 as a negative. But yeah, good. How about this guy? Maggie, walk me through this guy real quick.
Okay, we do 3x minus 2x.
Okay,
We get 1x.
good.
We take 9 minus 11.
Yep.
We get negative 2.
Okay, then what? Anything?
No.
Okay, good. Yeah, obviously if you have a 1x, you don't have to put you do not have to write the 1 out there in front. And then last but not least, Skylar, this guy.
Okay, find 3h times 5
Okay,
is 5 times 2.
also called what?
Distributive property.
Yeah, doing the distributive property there. 5 times 3h is 15h, right?
Plus 10.
Okay. Then what?
And then I did 3h plus 9.
Good. Just distribute that negative sign. Basically just changes the sign of your parentheses, right? Good. Then what?
And then I added my term.
Good. Here and here. 15h and the negative 3h are like terms, right? Good. And then any more like terms? Right. Good. And we're done. Very good. And guys, we will, like I said, even when we're solving equations, we'll still work on simplifying. All right? Now, speaking of solving equations, how do we go about doing that? Well, there's a little bit of a process. And the nice thing about algebra is there's a step-by-step process for doing everything. Okay? It's very concrete that way, very sequential. If you're solving for a variable, first thing you want to do is isolate. What you want to do is isolate the variable. Okay? Make sure that we get that guy with a coefficient of 1 all by itself on one side of the equation. Okay? How do we do that? We undo addition and subtraction with its inverse. And you guys talked about, answered this before, but obviously, excuse me, the inverse of addition is subtraction, the inverse of subtraction is addition, and then also we're going to undo multiplication and division. Now, that is basically the order in which you do this, right? If you want to isolate a variable, then you're going to want to undo your addition and subtraction first, and then undo your division and multiplication after that. Okay? That's pretty much the order we want to do this in. right? So, for example, if we have an equation that says g plus 2 equals negative 8, okay? G plus 2 equals negative 8. Then I want to isolate the g. I want to isolate that g. Right now, it's not all by itself on one side of the equal sign. It does have a coefficient of 1, which is really nice for us, but it's not all by itself. It has a plus 2 sitting next to it. And so the first thing we want to look for is to undo that plus 2. The inverse of adding, again, is subtracting. So I'm going to subtract 2 here. Okay? But what I'm trying to create is an equivalent equation. Right? I want to make sure that I don't change the equation. I want whatever I get when I subtract 2 there, whatever I get after I'm done doing that, I need it to be an equivalent equation. It needs to have the same solution. I don't want to change the solution midstream. Right? So if I subtract 2 here, the way to maintain an equivalent equation, to make sure that the next equation that I come up with when I subtract the 2, is to also do it on the other side. Yeah. So we're going to subtract 2 on both sides. In an equation, whatever you do to one side, you have to do to the other. You have to. Okay? And since, and again, the reason why addition and subtraction undo each other is because if we do this, if we subtract 2 from both sides, and you'll see it written like this very often also. And so I'll write it a little bit different way. Subtract 2 here, and to maintain the equivalent equation, subtract 2 over here. And the reason why we do that is because now if I take 2 minus 2, you get what?
0.
Yeah, and g plus 0 is just
G.
Exactly. Okay, that's why these guys are inverse operations. They add to 0. They don't cancel, they add to 0. Okay, and then obviously we work out the other side, we simplify the other side. We take negative 8 minus 2, we get negative 10. Okay, now we've isolated g. It's all by itself. It has a coefficient of 1, and we're finished. This tells us that g has a value of negative 10. The solution to that equation is negative 10. Okay? Same deal with the second guy here. We want to solve negative 6x equals 27. All right? And so our process, we want to isolate the variable. We want to get that x on it all by itself on one side of the equal sign with a coefficient of 1. Okay? And so we take a look. We find the x. It's on the left side of the equal sign. And now we start to look. Do we have any addition or subtraction to undo here? Okay, that's the first step, right? Undo addition and subtraction. Do you see any addition and subtraction around the x?
No.
Okay, but the negative 6 is sitting next to the x. And so that tells us that means negative 6 times x, right? So there's no addition and subtraction so far that we have to worry about undoing. Okay, but, so we move on to the next step. The next step is undo multiplication and division. We've got negative 6x there. That means negative 6 times x. The way we undo that is to, instead of multiplying the x by negative 6, we want to
Divide.
You got it. Okay? And again, to make sure that the next equation I come up with is equivalent to the first one, we've got to do it here as well. That's how you make equivalent equations. Okay? Now, negative 6 divided by negative 6 is what? They don't cancel. Negative 6 divided. Now, every time you guys say cancel, I'm going to yell at you a little bit. I know that's what some teachers may say, but we don't hear. They don't cancel. Negative 6 divided by 6 gets you what? What's negative 6 divided by 6? Or, sorry, negative 6 divided by negative 6?
1.
It's 1. Okay, it divides to 1, right? So when I take negative 6 divided by negative 6, I know I get 1, and so I still have this x here. So we get 1x. Now, 27 divided by negative 6. Okay, we can leave that. And again, fraction bar means divide, right? That's another sign for division, is that fraction bar. So it just becomes 27 over negative 6. Would be nice to reduce that. Okay, now we're not going to make equivalent, we're going to make an equivalent equation, but we're going to do that by making an equivalent fraction, 27 over 6. Right, and we can divide 3 in the numerator and in the denominator. And get negative 9 over 2. I'm letting my negative sign float, which is okay. I want to make sure I'm not confusing anybody. Right? Now, what was the goal? To isolate the variable, you got to get it on all by itself on one side of the equal sign with a coefficient of 1. Does it have a coefficient of 1?
Yes.
Yes. Is it all by itself?
Yes.
Yes. Do you have to write that 1?
No.
No.
No. And so now x has been isolated. All right? And so your solution here is just that. X equals 9 over negative 2 is an equivalent equation to that guy right there. They mean the same thing. Just the bottom guy tells you that the value of x is negative 9 over 2. All right? What about a guy that looks like this?
Yes.
All right? Same deal. Got to get a coefficient of 1 on our variable. Variable's got to be all by itself on one side of the equation. Okay? So what do we got going on? Is p all by itself? Does that have a coefficient of 1?
No.
I think it has a coefficient of 1 the way it looks right here, right? But you're right, it's not all by itself. So, what are we going to do, Tommy?
You multiply by 3 on both sides.
Why are we multiplying by 3?
Because the fraction bar means divide.
Right. And we want to undo that,
Yes.
right?
Yeah.
So we're going to multiply both sides by 3.
There would be p equals 15.
Okay, good. And again, why? Right, if I were to create the equivalent equation here, if I'm going to multiply this side by 3, the p over 3 is already a fraction. I'm going to make this guy a fraction and multiply straight across. I'm going to do this a little bit slower than what Tommy did. 3 times p in the numerator, get you 3p. 1 times 3 in the denominator, get you 3. That's how you multiply fractions, right? And then 5 times 3 is 15. But then we have this 3 divided by 3, which again divides out to 1. Okay? And again, if you have a 1 next to the p, you don't need it there, so we can erase it. So yeah, now our equivalent equation becomes b equals 15. Good. All right. Travis, what do you think? What'd you come up with?
I came up with x equals -18.
I like it. Good. And how'd you do it?
Multiply 2 by 2. And I multiplied it by 2.
Good. Good. Okay, those 2's are going to divide out to 1, which is why they're inverses. Right? Multiplication and division, we want to make sure that those guys multiply or divide out to 1. Addition and subtraction, we want to make sure they add or subtract out to 0. That's why they're inverses. Okay, good. Naomi, how'd you do it? Do what with reciprocal on both sides? You subtract the reciprocal from both sides? Multiply the reciprocal. The reciprocal of what? What in the world's a reciprocal? What are you talking about? The reciprocal of a fraction is just flipping it over, right? Making the denominator the numerator the denominator. We're going to multiply that. Why? Why are we multiplying by the reciprocal, Naomi? We want the coefficient on x to be a what? What do we want the coefficient on x to be? What's the goal? We want it to be 1, right? We want it to be 1. That's the deal. X all by itself on one side of the equation with a coefficient of 1. So we've got to find some way to take, right now we've got 2/3 times x. We've got to find some way to make that 2/3 into a 1, right? And so when we multiply by the reciprocal, we know that reciprocals, when you multiply them together, always give you 1. Okay? 2 times 3 is 6. 3 times 2 is 6. 6 divided by 6 is 1. So, yep. Multiply by the reciprocal here means we got to multiply by the reciprocal over here, right, Naomi? Okay? Do some cross simplifying here. 1 times 1 is 1 on the numerator. 1 times 1 is 1 in the denominator here. So technically you get 1 over 1x. Well, that's silly. 1 divided by 1 is 1. And we know that if it's just 1, we don't have to worry about writing it. Right? Now, what happens on the left-hand side, Naomi? Okay. Let's make this 6 a fraction. And then we can cross simplify, right? Divide 2 into 2 one time. Divide 2 into 6 3 times. Right? And then for fractions, you multiply straight across. 3 times 3 in the numerator. Get you 9. 1 times 1 in the denominator get you 1. Okay? 9 divided by 1 is 9. So x should be 9. Good. Okay? You want that coefficient to be a 1. If it's a fraction, then like Naomi said, multiply by the reciprocal, and you'll be in good shape. Okay? All right. Try that again here. We got it? Tell me what to do, please. Adam? Got to isolate the variable, right? What's that called? We're flipping that fraction over. What's that called? What's 4 over 7 called for 7 over 4, Adam? A fancy word. Help him out, Tommy.
Reciprocal.
That's it. Reciprocal. All right. So, Adam, we're going to take, and we're going to do what with the reciprocal? Multiply it? Okay? So is the reciprocal 4 over 7? Okay, good. Remember that when we multiply that fraction coefficient by its reciprocal, we need to make sure we get positive 1. And to make sure that happens, we got to multiply it by 2 negatives. Can't talk. Okay? And again, to create an equivalent equation, we got to make sure we do it to both sides. Okay? Now, at this point, a fraction times its reciprocal, we should understand that you just get 1. These multiply out to give you 1. And that's what we want. We want that coefficient to be a 1 on x. Okay, good. And now you got to find a way to multiply these two guys out. Adam, what do you get when you multiply these two fractions out? Negative 3 over 2. Because 7 goes into 7 once, 7 goes into 21 3 times. We can cross simplify. 4 goes into 4 once, 4 goes into 8 twice. Numerator times numerator, 3 times negative 1 is negative 3. 2 times 1 in the denominator gets you 2. So indeed, it should be negative. Okay? Good. All right. Those are all called one-step equations. Why? Yeah, because you only need one step to get the variable by itself with the coefficient of 1. Okay? Next up are two-step equations. Okay? Because if you're going to try to isolate the variable, and this guy right here, we've got a couple of things we need to do. And if you go back through your notes to the list where it says solving equations, the very first thing it says to do is to isolate the variable. And the first thing you need to look for is to undo any addition or subtraction first. So when we start getting into two-step equations like this, you find your variable, find which side it's on, and then start working through that. Right now we have an x here, and we have 2x minus 3. We want to undo the subtraction first. We have to undo the subtraction first. Okay? So, we want to undo this minus 3 by adding 3. Right, Maggie?
What?
You all right?
Yeah, I'm good.
Okay? And again, to make sure that we maintain equivalent equations, we're going to do the same thing to both sides. We know that negative 3 plus 3 gets you 0. They add to 0. And that's how we undo that subtraction. So 8 plus 3 is 11. What's left over here is 2x. This is an equivalent equation to that. They have the same solution. They don't look the same, but they have the same solution. Okay? Now, our x has been isolated, but it doesn't have a coefficient of 1. And so just like before, we've got 2 times x here. We undo that by dividing by 2. That divides out to 1. Now we have our coefficient of 1, and we're there. Okay? Issues, questions, concerns there. All right, try that guy. Oh. Gotta do that first, right?
Yeah.
Okay? What happens? What's our equivalent equation then? Okay, once we simplify, we get an equivalent equation of that. Okay, then what's next?
Divide by -3.
Good. And our equivalent equation becomes?
I think it
Equals what?
9.
Okay, good. Any major issues getting there? Okay, got another one. Try that guy. How about it, Kessler Steel? PI?
1 equals 10 plus 170. 170 equals 10.
So we're going to add 10?
Yeah.
Okay. If we add 10,
Subtract it.
what?
Subtract.
Oh, why subtract it?
It's positive.
The 10's positive, right? So we want to undo that by using subtraction. We want the 10 to add or subtract out to 0, right? That's how that happens. Okay, now we need to simplify and get to an equivalent equation. That equivalent equation should look like what, Kessler?
Well, then you get 160 and you divide it by 16.
So this is 160. Well, I want to make sure we're rewriting our equivalent equation. Right, so we get 16m equals 160. That's our equivalent equation. This equation means the exact same thing as that guy. They have the exact same solution, just looks different. That's all we're doing, making it look different, right? Okay. Has the variable been isolated, Kessler?
Like, yeah, it's on one side.
It's on one side, but it doesn't have a coefficient of 1 yet.
Oh, yeah, so then you divide it by 16.
Okay.
And then
And then your equivalent equation will look like
it's
m equals 10. This guy is equivalent to that guy, which is equivalent to that. Uh-oh, Braden. Needs to be negative? Why? Ah, yes. So I was able to trick one of you. That minus sign has to be carried down as a negative. Okay? And here's why, and this happens a lot. And so I'm glad this came up. Okay? Because this happens a lot. If we go back to this, right? We want to undo this addition by subtraction. So I'm going to subtract. That's a positive, right? So I'm going to subtract negative 10 to that positive 10. And the same thing here. Well, if we just were simplifying, this negative 10 plus 10 is 0. And of course, 0 minus 16m is negative 16m. So we got to make sure we carry those minus signs down as negatives. Okay? All right, so we're good. Subtract 10 here. This would be negative 16m. Okay, and then divide by negative 16. So it should be negative 10. Okay? I keep pointing this out, guys. These are equivalent equations. They mean the same thing. They have the same solution. They just look different. Okay? It's a lot easier to tell that the value of m here is negative 10 than it is if you're looking at that equation right there. If you're looking at 10 minus 16m equals 170, it's not so easy to see that the value of your variable is negative 10. That's why we're doing this, right? All right. Good. I'm glad that came up. We can take care of that and that not be an issue anymore. Okay. All right. A couple of story problems for you here, kind of like what we did through the warm-up. So I'll let you guys work together and get these equations with an added step here, and you see that in your directions. Define your variables. Right? Define your variables. So when you decide on one, go out to the side and write out what that's supposed to tell you. Okay? Give that a shot. Trip can hold 65 students. You have room for 13 more. How many students are already on the bus? Define your variable first. What do you not know?
How many kids are already on?
Right. X is fine. M was suggested. Any variable you want is fine. X is fine. Here, M is number of students on the bus. And anytime you're working with a story problem, you're going to write an equation to model it. You need to make sure you're defining your variables so everybody knows what the variable stands for, right? Now, however many students we have on the bus, we know there's 13 more that we can put on there, right? 13 more than means plus. Right, and we can possibly put 65 on there. Okay? How many students are already on the bus? Now we've got an equation that we know how to solve. One-step equation. I don't know. Why not? Since we can now. Why not? Okay? So M is 52. Okay? Any major issues there? Got it? Kyle Salter. Yeah, that's right. I keep forgetting. Kyle Salter. Don't have it yet. Okay. Help him out. Okay. Perfect. Only I don't know what in the heck X is. Okay. Okay. Good. Okay. Yeah. And X is, you said 5? Okay. Good. Writing equivalent equations all along the way. Good. Any issues getting there? Okay. The bill for the repair of your car was $390. That's what everything was equal to. It's what it totaled out to, however you want to look at it. Okay, now how did you get to the $390? How do you get to equal $390? You got to take the $215 for the parts and add into it the labor, which is $35 per. There's that word per. We're going to multiply 35 times something. Okay, good. Last guy here, and then we'll talk about algebraic proofs. Try this. Okay, so 250,000, is that what you mean? Say it again.
250,000 plus 750x equals 238,000.
Okay. What in the world is X? No, not the value. What do you mean by X, Ireland? We're going to define the variable. What's X represent?
When he withdraws each month.
Right. So when we solve for X, what's that going to tell us? Specifically. Sorry. Huh?
The money he withdraws each month.
No. It's the number of months that he's withdrawn the money. Okay? Okay? That's what I meant. It says how many months did he withdraw money? That's sort of your clue on how you want to define your variable. Okay? Now, next thing I want to know is if you start at 250,000 and you add stuff to it, how will you get to 238,750? You see what I'm saying? So if you're withdrawing money, you're actually, but you're subtracting. Guys, don't put anything up yet. We're not done. We want to subtract. Okay? Then we're going to go solve. Okay, your equivalent equation when you subtract 250k from each side is going to be negative, what, 11,250? Then divide by negative 750, and x ends up being 15. So he's withdrawn money for 15 months now. Okay? Good. Any questions, issues there? Okay. I want to show you this as well. Like I said, we're not going anywhere. We still got a good couple of minutes. Okay? Algebraic proof. Another way to look at it, it's a two-column proof. You guys will see these again in geometry. You'll do a lot of two-column proofs in geometry as well. But it's basically a step-by-step process on what we're doing to solve an equation. Okay? So, we're given this statement here. We're given this equation 2x plus 7 equals 15 here. And how you want, this is just a way to organize step by step what you do to solve this down, to get to solve this two-step equation, right? So you need a statement and then a reason. You need a reason for doing what you're doing. Okay, and for this first guy, 2x plus 7 equals 15, that was given to us. We have to start somewhere. And so you're going to be given some information, and the information you've been given is this equation. Okay? Now, we all know at this point the first thing you want to do is what?
Subtract 7.
Right. We're going to subtract 7 from both sides. Okay? Now, why? Why are we doing that? What allows us to subtract 7 from both sides? It's a property. It's called the subtraction property. Okay? Right now, all of these are going to be properties. And we're just going to call it whatever we're doing. So the subtraction property. Now, the next thing that we do is we come up with our equivalent equation by simplifying. So we subtract 7 from both sides, we get 2x equals 8. And then we're doing that because we're simplifying. We get 2x equals 8 because we're simplifying. So we just call it simplify. And then we all know the next thing we're supposed to do is divide by 2 into both sides. And what allows us to do that is what's called the division property, right? Again, it's a property that we're calling it what we're doing. Right? And then we simplify x equals 4. Okay? And so we call it simplifying. Right? Now, you've got one more in here. I'd love for you to do it on your own, but let's get this in. So 29 equals 5 minus 3x. That's going to be given to you. First thing we're going to do here, subtract 5 both sides because that's the, you got it, okay? And so on and so forth. I'll show these out. You guys can pick them up later.